Hi, welcome back to Math with Patrick. Today is January 22nd, and of course, we're solving the 22nd problem from this Daily Epsilon calendar. Okay, let's try it out. Looks like we have a word problem. In 2005, Alex is 4 times as old as Beth, Cal is 2 times as old as Beth, and Alex is 4 years older than Cal. How old is Beth in 2025? Well, apparently she's 22 years old, but we don't know that yet. Let's figure out why. I notice we have 3 bits of information here. We can relate Alex and Beth's ages, we can relate Cal and Beth's ages, and finally we can relate Alex and Cal's ages. And there's 3 things that we don't know. I don't know Alex's age, I don't know Beth's age, and I don't know Cal's age. So this is actually starting to feel like a system of equations for me. I know that when I have 3 unknowns, but 3 ways to relate them, I can solve for all 3. And that's what I'll do here. And a little side note, I think it's kind of cute when math problems name people after letters in the alphabet. Usually I use Alice and Bob for A and B, but I think it's cute that they're doing A, B, C, Alex, Beth, and Cal, just to have like easy names and easy variables to use to represent their ages. So let's create that system of equations. Alex is 4 times as old as Beth. That means Beth is younger. So I should multiply Beth's age by 4 to get to Alex's. Cal is 2 times as old as Beth. So similarly, I need to take Beth's age and multiply it by 2 to get Cal's. And then finally, Alex is 4 years older than Cal. So I need to take Cal's age, add it by 4, not by A. And then I will get Alex's age. There we go. So I have 3 equations and 3 unknown variables, and with this setup, I know that I can solve for all 3. Ultimately, my goal is to figure out Beth's age, so I should know B, but maybe it'll be easier to solve for the other 2 first. I'm not quite sure yet. Actually, you know what? Maybe it'll be easiest to solve for B. I see that I can use some substitution. If I replace this C with a 2B and this A with a 4B, then I have an equation purely just with B in it, and I can solve for that variable. So I'll use some substitution. This is a 2b based on this equation here, and this is a 4b based on the first equation. And I'll make sure that this plus 4 and this equal sign stays. Now I'd like to subtract 2b from both sides of this equation. That'll cancel out these 2b's over here, leaving just a 4, and I'm left with 2b on the right side. And now I can divide both sides by 2, and I get Beth's age as 2 in, what year was that again? 2005. So from 2005 to 2025, we can assume that she grows by 20 years. Maybe with some like weird birthday math, maybe it could be like 19 or 21, depending on how you cut it. But we can assume that from 2005 to this year, 2025, she's going to get another 20 years to her age. So if she is 2 back then, 20 more years, she is now 22 years old. All right, cool. Well, I guess that was about it. We created a system of linear equations, and from nice substitution here, we were able to just solve for B immediately. And adding 20, we get that she is 22 right now. All right, thanks for coming along. I don't have much else to add, so we're going to end the video pretty shortly here. I'll see you tomorrow. Okay, bye.